Good morning and welcome to the podcast.
Morning, everyone.
Podcast CAD Class. CAD Class Podcast.
It's still so ridiculously difficult to pronounce, and I kind of like it that every single week I get to hear Josh stutter. It's still so nice.
Yes. So, welcome to the CAD Class Podcast. I'm Josh.
I'm Jake.
And each week we answer your Fusion360 questions. We talk product design, and we go through our Discord and try to answer any of the tricky points that stumped some of the people in our audience. So I see Patrick Matheson there. Thank you for joining us, Patrick. It's really nice to have you.
How's it going?
Always curious. We'd love to know if you're joining us, if you're new, if you haven't already mentioned it, where are you in CAD class? If you're working through the book or the course or both. And then also, if you haven't let us know, we're always curious where you're calling in from. So let us know those things. Jake, we've got a couple of interesting things today, I think.
One of our bunch of really cool things.
Yeah, where do you want to start?
So I think our favorite place to start is always the shout outs, kind of showing off all the really cool stuff that people are making, throughout the week that we always really love. Sometimes it is some people making their own projects. Sometimes it is them working through the projects, and they just look fantastic. And we actually have some of both. So let me go ahead and share my screen real quick. Oh my gosh. How many weeks we've been doing this and I still don't know how to do it?
Yeah, I'm going to send out another note just so our... All right. And then...
All right, guys. So, well, this week, Desto was working on this really cool project where he essentially needed to have some casings or some casting to pour some molten metal into, and he's looking to make some of these looms to go into. I think it's bullet casings. I don't know, but essentially started off by making, these singular cones that go into all these individual things. And obviously, when you're working with molten metal, speed is your enemy, and so you really need to work as quick as you possibly can, because as soon as you slow down, well, the metal doesn't care about you. So you really need to kind of speed things up. So he was wondering if he could actually get, 2 of these bullet casings from just one pour, and kind of sketching this out. And immediately I just said, oh yeah, you need to loft these shapes. And he did it immediately. It took him no time at all. And from this, he learned about rails in lofting, which is a really kind of strange thing. So for anyone new, the idea of lofting is that you have 2 different profiles that are above each other.
Why don't you pull
regardless of what shape they are?
Why don't you pull a Fusion and just do a really simple loft?
That's a good idea.
Yeah, I think it's harder to understand when you're talking.
What? But my words are so succinct and clear.
They are. but then why do we use CAD if we can just talk about it?
That's very true.
Yeah.
So the idea is that you can have multiple different profiles on top of each other. It really doesn't matter what they are. I'm going to put a circle and a polygon. They can be different sizes. They can be at angles. They can be whatever they want. And the idea with lofting is that they will essentially merge shapes. So if you're going from a smooth round shape to an angular polygon, they will get perfectly morphed. And my kind of favorite thing is going through a section analysis so you can see all the different layers. So obviously it starts off as a perfect hexagon, and then the edges get rounded until it gets to a perfect circle. So you can get these really complicated organic curves, and you can make them relatively easily. This is the same process that we use for our surfboard project in Chapter 1, where we make... a surfboard is a really complicated curved body, and to make it essentially using 4 sketches, just 4 ellipses, and then the lofting tool and making this really fantastic large object. It's just super cool. And one of the things that you can do in lofting, because I only popped it up really quickly, is that you can also add in something called a rail. So a rail, currently there is no rail. So it's kind of looking for the most direct path possible. It's going, okay, here is the center of the circle, and here is the center of the hexagon. So we're just going to morph it following along that straight line. But if we have a rail, we can actually say, no, don't go in a straight line. I actually want you to go in a bit of a curve or a complete 90 degree. It doesn't really matter. So we can do things really, really wild. Excuse me, I'm still getting over my sickness a little bit. So if I do something a little bit more interesting, actually no, I'm going to move this over. Let's say, oops, let me just delete that really quick. Let's say that I'm going to make a 50 millimeter circle, and its radius, or excuse me, the distance between the origin and its center. I'll actually make that 50. Make all the numbers nice and even. Is also 50 millimeters. And then I go to a completely different plane and make a, let's go for a hexagon. That's also 50 millimeters in diameter. And I'm just going to add on all of the exact same values for simplicity's sake. Then I can technically loft. Whoops, that is still undefined. Oh, it can still move left and right. Whoops. Rookie mistake. So we can actually loft these even though they are 90 degrees to each other. If we wanted to, we could just make the most direct path possible between these two. But another thing we can do is actually make an arc that just intersects between the center of these. So I can make a brand new sketch. You can see I have these clickable points right here. And I can just add in something like a 3-point arc between that if I wanted to. Very quickly, I can just make this into a quarter circle. Join up all of these points. There we go. And this is already fully defined. Now, when I go into the loft and I select my two profiles, it's going to be ignoring our arc. And you can see it's making this straight line loft. And then if I go into Rails, I can say, yep, I would like to add a new one. And I'm going to be selecting that curve. Whoops. The selected rail does not touch all of the profiles. ¿Por qué? That isn't true. What a great example.
Maybe change the arc to be a little bit less. I don't know. Fusion still, we talked about last week, we talked about Fusion disliking splines.
It really
does it dislike arc sometimes too? We'll see.
Sometimes, yeah. Fusion's is your best friend until it's not, which is kind of the truth of the matter.
And then it's your friend.
It's amazing and powerful, and sometimes it's your friend. You know. Yeah, it doesn't like it. Anyway, but going back to it, you can make all different types of rails. Let me see if I can do it on this.
Do it on the same plane,
parallel to each other. Yeah.
Actually, this shape is really interesting. So as we're talking about the next iteration of our book, that shape that you just drew, Jake, actually kind of looks like a. Do you know the mocha pot? Or is it mochi? It's like the coffee. Pot, it's like a coffee brewing device where the base is like hexagonal like that. It actually looks like that. It's got the hexagon attached to the circle. It kind of fades up like a lofted shape. You see these things before?
That's pretty cool. I have not. Yeah. For everyone that doesn't know, Josh is a big coffee person, and I'm a big tea person. I've never. Oh, it doesn't like it at all. The selected rail does not touch all the profiles. Well, yes, it does. It actually completely does. How strange. Oh, there we go. Oh, I was using the guide. Okay. Yeah, no, it's totally my fault. All right. So the guide type right here for the rails. So I had, so there's two different types of rails. You can have it where it's essentially the rail is touching one of these outer points, or you can have it on the center line. So I essentially said, hey, this arc or this curve that I have on both of them was touching an edge, and Fusion was saying, no, it's not. And I was going, and it was going, nuh-uh. So very quickly, you just had to change it to the center point. And then you can see you get this really funky, bizarre rail from this. It is still morphing between a hexagon to a circle, but it's now got this very strange windswept shape. Super complicated. This is a really, really hard shape to make without the lofting tool. This is also something that you literally could not make accurately with traditional manufacturing. You had to use lofting and you had to use computing to make all of these perfect shapes. So let me try it on this one again. So I'm going to go ahead and I'm actually going to be fixing this because I know this does work. Let's define. There we go. All right, let's try this again. Lofting. There we go. Selecting my 2 profiles. Selecting my rail. It's going to say no. I'm going to say it's the center line. Try that again. There we go.
Hey.
Yay. We know what we're talking about.
And this is so this lofting functionality here too is really nice when you have to connect two things in the real world. So if you're looking at an object like this and you're like, hey, when would I actually use something like that? Yeah, for future robot projects, Jostri says. Yeah, so anytime you need to connect two odd shapes and you want to do so, like you see here at a weird angle, like this really, and then if you have access to a 3D printer, which if you don't already, you can get an Ender 3 sometimes for as low as $100. You should have one.
Oh yeah.
But otherwise you would have a hard time connecting these shapes with traditional manufacturing techniques. So really interesting to have this functionality in Fusion, and also to have access to 3D printers that can make wacky stuff like this.
I think for me, the really funny thing is that you basically have 2 options if you're trying to solve a problem. For example, a hexagonal tube or a square tube going into a round tube doing 90 degrees. It's either make it in CAD and 3D print it. And if you have the very basic skills to do this, like this took no time at all, that's maybe a 20-minute job. Or you have to sculpt this and like cadaver it with duct tape and piping, and it's a nightmare, and it would leak and it would be awful. And it's like, yeah, it really doesn't take all that much time.
Did you just say cadaver it?
Yeah.
What does cadaver it mean?
Well, I think you know what a cadaver is.
I do.
Where it's not. Yeah, cadaver means to cadaver something. It's like to make something, but it's not very useful. It doesn't work.
I've never heard cadaver used as a verb. That's hilarious.
Oh really?
That's hilarious. That's fun. Never heard that. Yeah.
I think that might just be an English
cadaver
expression.
It. I don't know. Like, whoa.
Yeah,
that's more of it. MacGyver. Yes, MacGyver is the word we would typically use.
No. But MacGyver is when you do something and it works. It's like, oh, I'm kind of, I've used a stick of gum and a paper clip and I've made a cell phone. But oftentimes you do that and it doesn't work. Yeah.
I like it. I'm gonna try to sneak that one into some conversations today. I'm not gonna say anything. Yeah. I'm just gonna, let's just cadaver it.
Sorry, if you are mini rant, if you are describing a barge or something that you've made really, really quickly with minimal equipment, and you're trying to solve a problem and it does work, that happens 1% of the time. If that ever happens, you go, oh, awesome, it works. Most of the time it doesn't work. So why wouldn't there be a word for it? Yeah.
Yeah, Patrick says
it's like when the shortcut turns into a long cut. It's like, yeah. Anyway.
Too funny. Cadaver it.
All right.
Word of the day.
There we go. So this is
awesome.
Yeah. So this is the loft function. Very, very easy. What did you say the coffee thing was called?
It's a mocha pot, I think. Is it a mocha? Or no, it's a. Yeah. MOKA. Look it up. MOKA pot. So when we're talking to Ed, about building out the same
spell it out for
series,
me.
Mocha, MOKA, yeah. And it's these little coffee pots.
Oh, I know exactly what you're talking about.
So the base
in my mind, it was something completely different.
So the base of that coffee pot is lofted. You can see how it's like got the angle, right? Like,
no, I don't think it is actually.
How do you think that's made?
Are you saying the angle on this? That curve?
The bottom.
Yeah.
The very bottom part. Yeah.
Yeah, those curves. So that is just I'll actually show you. That is actually just a chamfer cut on a hexagonal cut. I'm gonna ruin your day, Josh.
That's definitely gonna ruin it.
Yeah. All right. Very, very simple. Yada yada. So the idea is that you're treating it like like you're making this on the lathe, and you are wanting to get rid of the sharp corner. Okay. So that's the idea that you got to keep in your head. Click on the front plane. Turn that body off. There we go. So, so if I'm just coming at this with a triangular cut, and I'm just going to do essentially a triangular revolute cut that we've done a million times in the course. I'm really not looking to make it accurate at all. Let's say this is going to be, 1 millimeter. That's fine. Move this over to the edge. Let's do a revolve cut of this profile about the z-axis. And I'll make that just a little bit bigger, just so it is actually cutting all the way through. I'll pin that down. Push this up to 3. I don't know. There we go. So you can see this kind of pointed skirt. So for all of you guys that don't know about metal turning, the idea with doing the triangular revolute cut is that we are essentially reenacting putting a cutting bit at a 45-degree angle and then just moving it in towards the spinning material. So if you have something like a cylinder and you are cutting off the flat end, it usually has an incredibly sharp corner that you don't want to touch because it can cut you. It's also very uncomfortable to hold. And so you usually chamfer it. One of the ways to do it is to get a file, and while the cylinder is spinning, to just kind of hold it at a 45-degree angle and then shave that off. The other way to do it that's a little bit more accurate is to just take a cutter, hold it at a 45-degree angle, and you can either push it towards it or to the left because it doesn't really matter. It's a triangle, and it will then start to cut off a little bit by a little bit. And the more that you push this tool into your cutter, the more aggressive of a triangular cut you get. And when you've got a cylinder, obviously it's just a chamfer, not very exciting. But when you've got a hexagon like this, where these points of the hexagon are obviously further out than the flat sections, the center of this flat section, then those don't get cut as much as the outer points. And so you get this really nice flared skirt kind of crown shape, which does look very cool. It does look very cool. So that's where you get, all these flared corners. But I do like this as like a super duper simple project.
Right? Yeah. So that was Ed. So Ed was saying, "Hey, yeah, this is like kind of reminded him of the mocha pot," and these are pretty iconic. I'd say.
I would say
kind of
so,
neat. Yeah, kind of neat.
Yeah. It's so annoying because I don't like coffee at all. I hate the taste. I hate the smell. I've never drunk an espresso. I don't like it at all. But all of the contraptions and the espresso machine and the frothing and the time and effort and the grinding, I like that.
Mm-hmm.
I really do. Mm-hmm. I like all the attention and minute chemistry and science towards it. I dig all of that. I just unfortunately don't like the end product. It's like there's some beers that I absolutely I'm fascinated by how it's made, and then I drink it and I go, yeah, that's awful.
Howdy. Printed by John. Hello. Nice to have you. Yeah, I love, I think we're committed to quality, right? So I think you and I can agree that anything that is like well done and well thought out, even if we don't like the final products, both of us can get behind.
Yeah.
I definitely feel the same way about a handful of things. Like I can appreciate classic cars, for example. Don't really need to have one. Don't really need to fix it. But I like the craftsmanship that goes into it.
Yeah.
All right. So any other shout outs for projects here? We had...
Yes, actually there was. So one of the projects that we do later in the course, is we make an AI villain, cough. It's definite for legal purpose. It is absolutely not the HAL 9000 from Stanley Kubrick's 2001: A Space Odyssey, one of my favorite films in the universe. It is definitely not that. But he does look a lot like it. And this is later in the line in the rendering project, where we say, hey, you can make a CAD project, you now have got a ton of experience in making large assemblies and pulling everything in, and it looks fantastic. Adding in the colors, great. Now let's make it look like a product. And so you can see it's in this kind of really cool background. It's got all this kind of fisheye warping. It's at a really crazy angle. You've got lights, but you also have lights reflecting off of the metal surfaces. And that's because one of the things you can do kind of cool in the CAD universe or in the rendering universe is you can essentially just make a cylinder or any shape you want and then add on an LED appearance. So you can make any shape emit light. And then if you just put it just slightly behind the camera, then you've got a colored light. It's really as simple as that. You can treat it just like a photo shoot where you have a light with like a red gel on it or an LED light or anything. And so you get these really, really cool effects on there. So I really love this project, but we will be changing it around just a little bit. I don't know if you guys can see, probably kind of on the bottom, the screws all the way over the border of this. And when we were writing edition 1 of the book, we essentially added in one bolt or one screw here, patented it all the way along, and then mirrored it to the top side, and then did the same thing over here, and then mirrored it. Since then, very, very thankfully, Fusion has added a tool called duplicate joints, where you would essentially just add in one screw, add a joint so it's fixed in place. And then because we have something like 28 screws in there, you can literally just click the holes where that screw wants to go, and it just adds it in. There is no patterning and mirroring. It takes such a fantastically short amount of time. It's wonderful. So that will be put in the edition 2 of the book and edition 2 of our course when that comes out June next year. So be on the lookout for that. As always, if you guys have downloaded the book or if you guys are using the PDF online, that will always be free. That will always be updated. So any of the changes that we make in edition 2 will always be updated in the PDF. And if you buy the book and you actually want to verify if there's a different way to do it, or you're running into a couple issues, the PDF is always going to be updated with every single Fusion 360 major update that they do, which happens about every couple months at this point. They're putting in some really funky tools, which I love. Anyway, really fantastic project. Absolutely love it.
The HAL 9000, I think those are the renders we've gotten for HAL 9000 have been just incredible.
Yeah.
So if you go to the Discord channel and just kind of scroll through, it'll give you some inspiration when you get to that chapter. They're a lot of fun. Yeah. And it's not all that much work. When you really figure out how it works, it doesn't require a ton of time and effort after the fact. I think that's the really nice thing about this side of the program.
Yeah, a lot of people, they run into they start off this course going, I will never use the rendering workspace. And Josh and I are looking at each other going, yes, you will. I promise you. It takes such little amount of time to go from the CAD design to the actual render and then make a picture. So instead of getting like a screenshot of, some part in your project, you can actually render it and it looks fantastic. In fact, a lot of people in the fundamentals, they will just take a screenshot of their CAD design, and then let's see if there's anybody
that one
in here who's done.
Yeah, let's see here.
This one down here looks. Yeah, they took this into the rendering workspace. This probably took a couple minutes, and it looks fantastic. They've got drop shadows, they've got reflections on here, they've got it in a white background, they've got it positioned. It looks fantastic. There's a couple other examples. I don't think people are brave enough within the first week to do it. But certainly later down the line, there you go. A
couple people rendered it,
pulling in their Mobius strip and their paperclip into it. And it's
love
it. Yeah,
it's a lot of fun.
So easy
and satisfying to show off to other people when you're making stuff too. It's a little bit more realistic, which I find when you're making things, especially when you're drawing them on a computer, if you make them a little more realistic, it almost gives you the sensation that they're already built. So when people see those things, oh, wow, like I like that, or I want that, or I need that. If you're trying to sell something and somebody says, I need that, that's a good sign. So may as well
very good sign.
May as well make it look beautiful.
The rendering workspace definitely goes in very deep to show you exactly all the tools and what they mean, and a little bit about photography and photo design. But if you just want to, at the very beginning, if you are just starting, if you going from the design just to the rendering workspace and then rendering it, and you literally do nothing else, you will get a perfectly perfect
Perfectly
design
perfect.
A
Perfectly perfect.
design
Perfect.
for
A
this.
perfect. A perfect.
I couldn't think of another word.
If you're just coming in, if you're just joining us in the stream, it's really nice to have you. Don't forget to ask your questions in the sidebar if you do have any questions. If not, Jake, I think we're gonna jump off and we're going to expand on the Strand Beast. No, before we do the Strand Beast, we had one more comment that I wanted to talk about. We had Jerry, one of our graduates of the entire program, an awesome guy, say Granger has CAD models available. So
Yes,
let's quickly show that. Yeah, let's show that functionality off. That's actually really neat, and it simplifies.
So really quick, for the people that don't know, there are a few companies in the world whose their entire business, and they've usually been around for 100 years, is they have every single nut, bolt, washer, motor, bearing, ladder you can possibly think of in every single material, every single size, and their entire business framework is specificity. So if you say, I want a 1/4-20 bolt, they go, I'm going to need way more information than that. There is no such thing as just a 1/4-20 bolt. There's so many different specifications. And so they have gigantic libraries full of, probably at this point, a million different types of different products. And so really nicely in Fusion 360, they have Mastercar, McMastercar, which is one of those companies where you can literally grab any different type of bolt or screw or soldering, anything you want, and there is already a pre-built CAD model. So if I say I would like a bolt, it's going to go, all right, inch or metric, we'll go inch. All right, what's the thread size? I want a 1/4-20. Where is it? Where's 1/4-20? And it's going, oh, okay, well, what length do you want it? Oh, gosh, 1/2 inch? Gonna go, okay, what's the head shape? I don't know, Allen? Okay. Oh, what coating do you want? What? Black oxide. I've heard of that. Okay. And it always is asking more and more and more specificity. And from this, you can then pull in a CAD model. So the original one is for SolidWorks, but you can just change this to a step file or an STP file, same exact thing, and it will pull this in. And it's already made, it's already textured, it's already accurate dimension-wise, and it's very, very easy. The downside with that is that if you're ordering from McMastercar, it is very, very expensive because it is so specific. And so another company that does a very similar thing is something called Granger. And so they are now coming into the scene of having CAD models for everything. And so we're just kind of playing around with this. So bring up Granger. So I just found...
The bearing is really cool. Yeah, that's really cool.
Yeah, a bearing of this. And if you look on the left-hand... yeah. So it also has a PDF of all the dimensions, stupid specificity and tolerances. It also has a CAD model here that you can... that I literally haven't looked into. So all these different things. I wonder if it has... So it's got a DXF. That's for 2D stuff. An AutoCAD, an SAT. Yep. An Inventor file. That's probably going to be pretty common. Step. Oh, they're actually different things. I did not know that. So we can change this around to any different thing. Let's say I want a step here, and this is what the final CAD model is going to look like. So I'm going to go ahead and download this CAD model. It's been generated. Cool. Download it. And let me pull this into... Let me see if I can pull it in directly from my downloads, actually. Will that work? Nope. So let me go ahead and... One thing for everyone, all of these folders in your very home screen, you can't delete them, but I absolutely recommend having one of them being test. This is where I just put in random projects that really don't need to be stored anywhere. So let me go ahead and select file from my downloads. I'll say Granger, download. There we go. It's 500 kilobytes. It is tiny. It's just loading. Let's pull that in. Ooh, it's taking a while to load. Oh, it's because we're streaming. That's why.
Oh, yeah.
Yeah. Using a little bit of bandwidth. But anyway, this is
You get
exactly
the
how you
point.
do it. You would
Yep, there it is.
you would
There it
upload
is.
this.
Yep.
So I'm just going to open this up as its own file, and there we go. We have all the ball bearings in there. It's probably going to have all of the bodies. Yep. So you could hide all of the individual.
Is there a timeline on
balls
that?
if you want? Usually not. Usually when you bring in projects, it doesn't show up how it was made because it's not a Fusion360 file. It is a step file.
Makes sense.
So when we bring in STLs from Thingiverse, like we do with the Silicon Skull project, it's just a mesh, and then we have to convert it from a mesh to a body. The nice thing about a step file, or a SolidWorks file for that matter, is when you bring it in, it's already converted into a body. So, for example, you can do anything you want with it. You can extrude faces. You don't need to go from a mesh, which is just a covering, to a solid body. It's automatically a body. The downside is that your timeline is now completely disappeared. The way that you fix this is by right-clicking the component at the top and saying, I want to capture the design history. So I want to bring that back. And you'll see there's only one timeline, and that's basically just bringing in this component. So it doesn't show you how it was made, but it's a really efficient way to send fairly complicated 3D models.
We do have a question. And
All right,
Sam,
give me.
So Sam dropped in, I made a thing. I believe that's for an old car that he's working on. He dropped a part in there and he said, let me go ahead and link this. It says, I have a model that is slightly too small. Is there an easy fix? I think.
Oh, yeah.
Well, it depends, right? So you can't just scale up and down if there's hole sizes that are specific, right? So so my question for you, Sam, is what part of this needs to be fixed? So when you say easy fix, it's like what part of this doesn't fit? Let's see if we can get an answer from him in there. So you see what I mean? Like it's pretty complex. So you can't you can't just select the model after the fact and scale it up and scale it down, because I'm guessing there's hole sizes in here, right?
Potentially. So there's a couple different ways to do this.
When I screw it down, it snaps. Well, I don't know. When I screw it down, it snaps. I don't. It's you can't just scale this thing up and down. I mean, you can click the whole thing and scale it, right? I was hoping for like a 1% size increase. That's probably.
Oh, that's probably fine. Yeah. Oh, you could just do that in your slicer. You don't need to do it in Fusion. Just go into your slicer, bump it up 101%.
You can also do it in
Fusion. You could do it in Fusion. Oh, absolutely.
Why don't we just show a quick little scale? It's in the scale. It's in the modify menu, I believe, right?
I have to send it to my email, and I don't want to show my email.
No. Just draw a random object, just a square or something, and we can scale the square, or that we can just.
Why don't I just do this bearing? Yeah. Let's do this. Okay. So so first off, if you want to get it from the size that it is right now to a specific size, you have to do a little bit of proportional math. So if this is let's say 1 inch in diameter, and you want it to be 2 inches in diameter, then obviously you need to bump it up 200%. If you want to get it to 1.5 millimeters, you need to bump it up 150%. Pretty easy. The tool for this is called Scale. So it actually requires a little bit more information than people actually think. So it's asking for the entities that you would want to scale. So I've just selected the body 2 right here. The point is saying, okay, from where is it expanding? Which is kind of a funky question, because you kind of think, oh, it's just kind of, what do you mean? It's just kind of growing. But you can scale it up from any point that you want. It looks like I clicked right there on there, but you can essentially put it anywhere. It does not matter one bit. For the uniform, you can change the axes, or you can make it uniform. We want it to be uniform. And the scale factor is not 150%. It would be 1.5. Because 1 in this case would be 100%. So if I want to make it 1.5, then it blows it up. And you can see that point that we have that's selected on there, that is what is staying in the same location, and everything is expanding from it.
Right, and to be clear, 1.5 is a 50% increase in size. It has become
Yeah.
So 1.01 would be, so Sam says like was hoping for like a 1%. So 1.01 would be the answer. And you can always
There you go.
also combine all the bodies beforehand. If you
Mhm.
have 25, 30 different bodies and you don't want to have to select each individual part, and you can combine them, you can scale it, and then you can you can deal with the scaling of the entire object as opposed to having to click each individual piece.
So, okay, I'm actually really happy, Josh. They have fixed a bug that has been in this program for far too long that
Okay.
I don't think you've ever encountered.
Yeah, let's see.
Oh my god, this is so nice. Okay, all right. So let's say that I am working on a project where I know I need to scale something up to 50%. So you go 1.5, 150%, great. And you then finish it, and then you go, oh, wait, no, I actually wanted it to be 140%, not 150%. You would then go back and open up this tool, and instead of saying 1.5, it now says 1 because it is now converted to that 1. So you then have to do the reverse math of saying, okay, well, it was 100%. Now it's 150, but I want it to be 140% of that 100%. And it was such a nightmare. So even if you typed in 0.99 to make it just a little bit smaller, it would then become the 100% because that's what it is now. Then if you type in, oh no, I actually want it to be 1% larger, 101, it doesn't go back to the original size. It was just this proportional nightmare. And so now it holds onto this dimension, which I'm so happy. I'm so happy. This is so nice.
PC
Oh,
Van Vliet, welcome. Nice to have you. He says a bug that's been bugging Jake.
yep. Oh my god, yeah. I
Yeah.
love this though. Okay.
And this is another question I think that was related to earlier. Does the body from a step also have the ability to make components move? E.g., could you make
Oh
this
yeah,
bearing
absolutely.
spin?
So, oh, absolutely. This is purely just a component that we pulled into an assembly, but obviously it's external, so you could pull this into any project. But the entire bearing is treated as one component. All of the individual parts, like all of these spheres and the cage and the inner and outer bearing, these are all bodies. So if you made this body grounded and then tried to spin this, it wouldn't spin like a bearing. One of the fundamental truths of Fusion is that bodies don't move, components do. So none of this is grounded, so I can click and drag any of it essentially, or I can't because it's there is no locking point on this. But yeah, you could only put another object around it or an axle in it, and the entire bearing would spin as one.
Yeah. So
Not
the answer is
what it would
yes.
do in real life.
Exactly. So if you wanted this to spin, you'd have to have each of these be separate components,
Yeah, yeah. Which
or the
is,
two
to
outer
be
parts
honest,
be one.
unnecessary.
No, but it could be fun, right? So maybe you want to show off some motion of this thing for some reason. In this case, it is
You
unnecessary,
could do, yeah.
but just more like a how does it work inside Fusion
Yeah.
thing here. Whoops. Good. So Sam, let us know if that little scaling trick helps you. You can like Jake was saying, you can do that in Fusion, but you don't have to. You can scale it up and down if you use Cura, right? You can use that. Your slicing software is amazing for stuff like that. And it looks like we're not big on Prusa Slicer yet, although I'm becoming more and more inclined to start using it. I think they've got some new functionality coming out pretty regularly. And what I had a reason for that. What was the reason for Prusa Slicer talk? Wow, I just totally lost my train of thought.
Are you talking about the MK4 potentially?
No, not talking about that. I was just going to say something about scaling. I don't know.
You can. So often, just to go off of that, there are certain things that, if you're in the 3D printing world, that CAD is fantastic at, and there's some things that slicers are fantastic at. There's usually a lot of crossover. moving things around is a very simple thing to do in slicing. It's sometimes a bit of a pain in CAD. Scaling is another thing where, as you can see, it's a little bit of a pain. It's a little bit of more of a multi-step than people expect to do in CAD, but it's really easy in slicing.
I know what I was going to say. I was going to say that the Prusa slicer is sort of working its way into the CAD space a little bit. So there have been some updates to make it more CAD-like so that you can actually edit and do some additional things you couldn't do in slicers before.
Yeah, there's a bunch of stuff like that. I think one of the things that they're adding is to put text or symbols and emboss it onto an object and put it any way you want. That's a really complicated computational action that you absolutely can do in CAD, and you can have a little bit more finesse and accuracy with it. But what they're able to do in their CAD software is, regardless of the complexity of the curves on the surface, whether it's a smooth or a round or a really ripply face or textured surface, doesn't matter. You can type anything you want and it will emboss it or deboss it onto that surface, which is fantastic. Really, really good.
PC Van Vliet says cutting a model up and then adding dovetails or connectors is now easy in Prusa Slicer. So yeah, that's the kind of stuff really cool, because before you'd have to think about how you're going to connect things, and you'd have to build that in your design. And right, if you had already designed the entire thing up, you wouldn't have been able to do that later. And then it says you can also wrap around text. I know that the multicolor, like painting functionality, is becoming more interesting in these things too, where you can have different colors printing out on your 3D printer, which, by the way, is just more interesting than I thought it was going to be. Like, I was like, oh, multicolor, who really needs that? But I really feel that it's similar to us teaching people how to render things in Fusion 360. It's just so much more interesting than I thought. It makes your design pop. It looks more realistic, and it feels really cool. So I was wrong. I was wrong. We've got about, we've got about 15 minutes. That's probably not enough to cut up this Strawn beast, is it?
To do the entire Strawn beast. So one of the things that we're doing, just a little information for our course that goes along with all those projects, and we're essentially making small changes to essentially every single project to improve it, to update it, get rid of the annoying, boring bits, and making it a little bit more satisfying to do all your projects. And one of the things that I really dig is working on a really late project. It's something called the Strandbeest. That is Dutch for beach beast. That's in our motion animation week. It is essentially a project where you have a mechanical input, and you can make a walking leg. So this was made by a mathematician / artist called Theo Janssen, where he studied all of the mechanical movements of mammals and different animals' legs, and kind of realized that there is a mathematical relationship between all of them that's pretty simple. You can change all of these, all the lengths of all these legs, but the actual motion itself follows almost every single animal that can walk. Really, really fascinating stuff. And he builds these gigantic, what's called beach beasts, out of like recycled PVC and tarps, and absolutely amazing sculptures. And he puts them on the beaches of the Netherlands, and they're all wind powered. It's a very windy country, super flat, and they just walk. And as designs improve, he's basically treating it a little bit like an evolution of the animal, where it can actually start to get better and better and better. Like, oh, I'm going to use, empty soda bottles to actually store compressed air from the wind, and then as soon as the wind dies down, it then gets released, and it does this automatically. And so he basically released all of these really incredibly important dimensions and proportions. And so we get to make one of the legs, and I really dig it. And one of the things that you can do with this, if I show the joints, object visibility, show up the joints, I believe it's this one, where we want to then drive the joints. I want to drive all of them, is that you can animate every single joint in the entire project. I really love this. I'm planning on making a much larger Strawn Beast. I used to make these all the time as a kid out of Lego, but I'm planning on making like a large dog-sized one, where it's got 12 legs, 2 different motors so it can actually drive. That's the plan. Fingers crossed if I can do it. But I really love Strand Beast. But having one leg isn't super duper exciting. So one of the things that we're going to be doing in our next edition is to say, all right, not only are you going to be mirroring it to make 2 legs that move at the same time, but then also make all 12 legs, basically pattern all of them along its length, and then add 120-degree counter rotation to all of them, so it actually does crawl like an animal, which I've been wanting to make for so long. One of the ways to do it on small scale was to essentially have a crankshaft, just like you'd have on an engine, where all the pistons are moving at different intervals. But that's not really doable in 3D printing on scale, because you'll have a bunch of torsion and twisting, and that's a lot of stress to have on a system. And just this week, one of the guys that everyone should be subscribed to, a guy on YouTube called JBV Creative, one of the guys that we got to interview at Open Source 2023. Absolutely fantastic 3D printing guy. He works in SolidWorks, but he makes amazing contraptions. JBV Creative, if you aren't subscribed to him, do it exactly right now. He makes amazing content, and he just made a Strand Beast about the size that I was thinking, but instead of using a crankshaft, he essentially just had a geared mechanism where you just put a pivot somewhere on the gear, just like you would have it on a train, where you've got a piston arm connected to, a flywheel. And I'm like, oh my God, that's genius. So we will very likely be pulling some inspiration from his design and incorporating that. So the Strand Beast, instead of having just one leg, we're going to be making it a hell of a lot more interesting. And because it is week 10, it's much later into the program. We're going to be expecting you guys to be much better at CAD. And so we won't be giving you as much information. So it's a little bit more of a challenge. But I don't think we have time to make the entire thing. We'll potentially be doing that next week. But that's coming down the line, which I'm really excited about.
Yeah, I'm wondering, do you think you can pattern one right now? Just to show the...
I don't know. So
I'm kind of curious as well. I'm looking at this going, Let's see.
All right. So first things first, our planes actually run through this point right here, but we would want them to run through that point, which means I need to have a plane that cuts through the center of this circle. So I actually don't know if I can do an offset plane and just click this circle, which would put it at the center. I don't know. Let's try it out.
We're going to find out.
Yeah, I'll capture that position. That's fine. An offset plane. Let's turn on the origin. Let's click that on. It's going to say, all right, to where? I want to say to an object. So it's looking for points. You can see this little white dot right there. So I don't have a point on there.
So you can just make a point in the middle of it?
So I can make a point. Point at vertex. Point at the center of a circle sphere. There we go. Capture that. Click on there. Great.
I did not know that was an option. I did not know that was an option. What?
Yeah.
What?
So construct. We basically I personally only ever use offset plane, mid plane, some of these, but it's split up into 3 sections. You can do planes, axes, and points. I very rarely use points. I sometimes use axes. In week 10, we make a robotic hand that you can program all of its movements, and we do use axis going through cylinder, but I basically just make planes. But yeah, some handy tools. So I'll click on that point. There we go. Now we've got this plane runs exactly through the center of there. And I actually don't want to... Ooh, this is a good question. So I actually don't want to mirror it, because then it would run into that. How would I do this? I don't know. I'm going to say the components.
PC Van Fleet says, Josh, Jake brings the gold every stream. I do know that.
So I could mirror this, but then it doesn't mirror. So you can't mirror joints. This is why it's such a good project. I probably need more time. So
that's a cool structure. That almost looks like a mechanical grabber arm too. Like if you had I bet it would.
I'm
this is
very,
interesting.
very, very quickly going to be adding in all of the joints. This is going to be a bit of a speed run. All right, so I want to say these two components where the axis is about that center. Great. That's just fine. This pin right there, that wants to be totally grounded. Where is this component? There it is. All right, let's ground this bad boy. Okay, I'm going to be speed running through this as fast as possible. Yep, that's fine. Add another one. Boom, boom, boom. Great. I am almost positive that I'm going to be missing one of them. But that's fine. I'm just looking at the clock, seeing like how much time we have left on the stream. Like,
10 minutes. Make a group and mirror.
Make a group. So I think you mean combine. So actually mirror the assembly, which would. You could do that. The problem with what I'm doing right now, as I'm sure some of you have already seen, is that I have two components that are overlapping each other. So this will probably work in the mystical world of CAD, but it probably wouldn't work in real life. You have to mirror and move all of these. So again, with zero prep, I'm absolutely not doing it in completely the right way. So two joints there, one joint there, one joint there. Two flags there. Okay, this should work. Fingers crossed. I actually don't know. Let's see if I can animate this one. So that one should work. Okay. I knew I was going to miss one. All right. So one of these flags is for the left. Hey, there we go. Okay. That looks fine. So then if I want to actually make them, if I can get them perfectly parallel to each other, that'd be cool. I think, yeah, that sounds about right. And then I'm going to be adding a motion link between, that's fine, between these two joints. So they are absolutely equal, but reverse. There we go.
Zoom out. Let's see what it looks like.
This is totally not what it looks like in real life. I mean, it's almost what it looks like in real life.
It's a little trippy.
It is super trippy. You got, in the mystical world of CAD, we've got parts that clip through each other. Yeah. For any of you guys that want to have a bit of a challenge this week after this stream, if you want to skip forward to chapter 10 in the book or chapter 10 in the PDF and try this out, definitely. If you can figure it out, post it to our Discord. We'd love to see it. All right, man. Do we have any final questions before we wrap up this stream?
Questiones. Yes. Do we have any more questions? Questions in the chat.
God, this thing is bizarre. I can't believe I screwed up so badly.
I mean, you did it in what, 3 minutes? PC Van Vliet says, I'm running behind on the book. Been swannowed?
Swamped.
Swannowed.
Swamped.
I just figured this was another word I wasn't familiar with. With a makerspace, I'm learning all the new skills needed for that. Did a lot of laser cutting and engraving this week. Yeah, laser. Did you know, by the way, you can laser cut from Fusion? So you want to quickly show that? How you export as a DXF? So if you wanted to laser cut this stuff, PC Van Vliet, if you didn't already know that, maybe you do. In that case, sorry. But how would we laser?
Really quick. Also, part A, I actually don't know which bit that is. What's this bit? There we go. That B. So this shape where it's a slot with two holes on either end has a sketch. You can right-click any sketches and say Save as DXF, which is the 2D profile of any sketches that you draw, and then you can pull that into a laser cutting software and cut it. It's very, very easy. It takes no time at all.
Except when the DXF format gets all screwed up, which it sometimes does.
Yeah.
And I don't know why,
but it's very
frustrating because didn't Autodesk invent the DXF? Was it
They invented
Autodesk?
either the DXF or the DWG, which, as far as I know, are technically the same file type, but they're different for some reason. I don't know. I'm sure there's some computer guys that will tell me I'm completely wrong.
Right.
Which I'm sure.
Right.
I'm
You're wrong.
sure I am.
Yeah. I have no idea either. So I can't
But
pretend.
this is a way to do it. You can also do go into the manufacturing workspace. I believe you can go into. There is some tools for this. Where is it? Yeah. There's cutting. You can do laser cutting inside Fusion if you want to.
Oh, I didn't realize that. Actually, I've done
I have not played around with this at all.
So I have played around with maybe I'll show that a little bit next week, but I have actually played around with the Fusion Slicer now.
Yeah,
because I'm using that in my class. The additive workspace is kind of fun, and honestly, like I wouldn't use that slicer in the majority of cases, but it is a really nice introduction to the manufacturing workspace.
Absolutely.
It's nice to just
get
used to how they do it.
All in one software.
Yeah, you don't have to go out. You don't have to export the file elsewhere. I still don't really use it all that much, but it is nice to introduce that.
As far as I know, of what I've heard, which is very little, the additive software for an FDM printer is fine. It's okay. It's got some quirks to it, which they all do. But apparently using this for an SLA resin printer is actually... I've seen the results that people are getting from it. They look great. They look really, really good.
The results are
and
good.
You're actually able to then stack them. So if you're printing out something, relatively small, you can, because it's all structure, you can put multiple next to each other into a grid, but then you can actually have, a cube of grid of objects that you can print really, really easily to fill up your entire build volume. So super, super cool. Excited to see where that goes.
Sam says, wouldn't be a bad idea to clip this portion and post it as a standalone video. When I figured this out last year, it took too much research because no YouTube video. I didn't know that, actually. We'll add that to our shorts list. We'll make a short on that.
We'll absolutely put that into our shorts list. Or just tell people to watch this entire podcast.
Or you just got
20 seconds.
You got to come hang out with us. Yeah, I agree.
Yeah. All right, man.
Cool. Well, it's been good hanging out. Thanks for the questions. As usual, go ahead and hit that thumbs up. Give us a like. If you've got comments, questions, ideas, leave them in the Discord for next week. Anytime you post something in the I Made a Thing, we try to show it off. Most of the questions that come up inside of Discord, we try to answer both on Discord and in here. So if you have any, leave them on Discord. Till next week.
All right, guys.
I'm Josh.
I'm Jake.
And that was the CAD Class Podcast. Cheers, guys.
Adios. Peace.